Hi everyone, we are on day 2 of our quadratic functions unit. The note page you're looking at is interpreting quadratic functions from graphs and tables. So in this unit we're going to really start getting into the real life applications of quadratic functions. So in the lesson prior we talked about all of the key features of a quadratic function, but now we're going to learn how to apply those key features to a real life situation. So in the first example, it says, in a study of the activities of dolphins, a marine biologist made a 24-second video of a dolphin swimming and jumping in the ocean with a specially equipped camera that recorded one dolphin's position with respect to time. This graph represents a piecewise function, f of t, that is defined by quadratic functions on each interval. It relates the dolphin's vertical distance from the surface of the water in feet to the time from the start of the video in seconds. Use the graph to answer the questions below. So the first thing I want to talk about is what a piecewise function is, because we haven't talked about that yet. So basically a piecewise function is just pieces of different functions put together on the same graph. So if you look at my screen here, you can see the red, the blue, and the green graphs. Those are all the different pieces. So there's actually 3 different parabolas that we're looking at here. Coming together to form a single function, which is known as a piecewise function. So the other thing that we want to point out here is that on the y-axis we're looking at the height of the dolphin in feet, which is really the distance from the water surface, and we are looking at that versus the time in seconds. So in the first part, part A, it says, describe what you know for sure about the actions of the dolphin in the time interval from 0 to 6 seconds. Can you determine the horizontal distance the dolphin traveled in that time interval? Explain why or why not. So if we look at the graph from 0 to 6 seconds, we're really looking at that first parabola. On my screen, it's the red portion of the graph. And so what do we know for sure about the actions of the dolphin at that time? Well, considering that the height is above 0, we can assume that at that time the dolphin is jumping out of the water. They're breaking the surface of the water. So why don't we explain this as the dolphin jumped out of the water at, I'm going to say at time equals 0 seconds, because really that's where that piece starts. And then I'm going to say, and back into the water at time equals 6 seconds. And then it says, can we determine the horizontal distance the dolphin traveled in that time interval? So the answer to that is no. We are not anywhere on this graph talking about the horizontal distance, like how far the dolphin can jump. It's really just about how high out of the water the dolphin is jumping. So sometimes people misunderstand what this graph is. They think it's almost the path of the dolphin, but this has nothing to do with the distance that the dolphin travels. It's really just about the height from the water surface, or the distance from the water surface. So we're going to say we cannot determine the dolphin's horizontal distance because I'm going to say this function models the vertical distance versus time. Okay, for part B, where will you find the values for which f of t equals 0? And explain what they mean in the context of this problem. So we know this function notation. We've seen this before. So what it's really asking you is, at what time is the dolphin's height 0? So we're looking for where are the points where my y is 0. So I'm just going to kind of put these on my graph right here so you guys can see. So there's 4 points where y is 0. The first point is when x is 0. So I can say f of 0 equals 0. When x is 0, y is 0. The next one is when x is 6. So f of 6 equals 0. The third one is f of 16. So when x is 16, y is 0. And the last one, when x is 24, y is 0. So explain what they mean in the context of the problem. Well, because 0 is the distance from the water, we can just say this represents the time when the dolphin is either entering or jumping out of the water. So I'm going to say f of t equals 0 represents the times at which the dolphin enters or jumps out of the water. Okay, part C. How long was the dolphin swimming underwater in the recorded time period? Explain your answer or show your work. So if we go back up to here, the time that the dolphin was underwater is represented by this blue section of the graph. So from 6 seconds to 16 seconds, that dolphin was underwater. So we would say 10 seconds. And to explain or show our work, I'm going to write between time being 6 and time equaling 16, dolphin's height was less than 0, meaning it was underwater. So I can show 16 minus 6, 10 seconds. Okay, part D. Estimate the maximum height in feet the dolphin jumped in the recorded 24-second time period. Explain how you determined your answer. So if we find what is going to look like the maximum point, it's going to be part of this green section of the graph. And I would say right about there is where that dolphin hits its maximum height. And so they're asking us to estimate that height. And so if I figure out what this is counting by on my graph, this is going up by 5s. And so it looks like it's just under 25, so maybe we could say 23, 24. We're estimating, so anything around there is fine. So let's say 23 feet. And what else does it say? Estimate the maximum height in feet the dolphin jumped. How did you determine your answer? So 23 feet we can say is the y-coordinate of the maximum point. maximum height, we would have said 20 because it was at 20 seconds. But they just care about the height, so we don't really need to say that. Okay, part E. Locate the point on the graph where f of t equals -50 and explain what information the coordinates of that point give you in the context of this problem. Okay, so now they're asking us at what time is the dolphin's height -50? So let's go back. And it looks like -50 would be -45, -50 would be this point right here. So at that point, our time is 11. So we want to say f of 11 equals -50, or if you were writing it as a coordinate, it would be 11 comma -50. And so explaining this, we would say at 11 seconds, the dolphin is 50 feet below the water's surface. Okay, so moving on from the dolphins, we turn the page. Now we're looking at a table. So the table below represents the value of Caleb's stock portfolio, with V representing the value of the portfolio in hundreds of dollars, and T is the time in months since he started investing. Answer the following questions based on the table of values. Okay, so we can see in the table we're comparing months to hundreds of dollars in the portfolio. And part A says, what kind of function do you think this table represents? How do you know? So you can probably take a guess that because we're doing quadratic functions, that it's probably going to be a quadratic function. But how do we know? Well, the best way to tell from a table that something is quadratic is to look for that symmetry. So if I look at my y values specifically, you're going to see that we go 325, 385, 405, it hits a maximum, and then it starts going back down, 385, 325. So right there is your symmetry, which makes me think that this is a quadratic function. So I'm going to say quadratic function. Because remember, if it was linear, our rate of change would be constant, meaning it would continue to go up by a constant amount or down by a constant amount. So when you see that symmetry, you know that it's quadratic. So let's say quadratic functions, since there seems to be symmetry in the y values, another thing you can say is there's a turning point. And if you look, the turning point is that 6405. You can really see either thing there. Okay, part B. Assuming this data is in fact quadratic, how much did Caleb invest in his stock initially? So what are they talking about initially? Well, that would mean that at the start, or when time is 0, how much did he have invested? So from the table, we can't tell what it is at time equals 0, but we can figure it out. So if you look, these months are going up by 2. So if I go backwards on my table and okay, the previous month being month 0, and I'm following this pattern, this symmetrical pattern in the y coordinates, my next value should be 225, just based on what's coming next right here. So we can say f of 0 is 225. Okay, and again, that's in hundreds of dollars, but that is good to write. Okay, what is the maximum value of his stock and how long did it take to reach the maximum value? So again, we've kind of already identified that with our part A here, but The maximum value we can see is 405, and that is after 6 months. So at 6 months, maximum value of 405 was reached. Now again, this is in hundreds of dollars, so if you want to, 405, you could be writing these answers like this. Okay. Part D, if the pattern continues to follow the quadratic trend shown above, do you advise Caleb to sell or keep his stock portfolio? So let's look. If we talk about month 20, month 22, and so on, what do you think is going to happen? Based on the pattern that we're seeing, we're going pretty deep into the negatives. So my advice to Caleb would be to sell because the value continues to decrease. So I'm going to say I would advise Caleb to sell his portfolio because the value continues to decrease. Okay, part E. How fast is Caleb's stock value decreasing between 10 and 12? Find another 2-month interval where the average rate of change is faster than 10 to 12 and explain why. So in the last lesson, we learned how to find the average rate of change over an interval. And so if we're looking at the table between 10 and 12, go back up here. So we are using, let me get rid of some of these markings on the table. So we are using these 2 points to figure out our average rate of change over that interval. So I'm going to go back here, and I'm going to write it out. So the first point was 10, 325, and the second point was 12, 225. So remember, to find average rate of change, we're really just finding the slope between those 2 points. So I'm going to do y2 minus y1 over x2 minus x1. Trying to get rid of that little mark so it doesn't look like a negative. There we go. Okay, so I'm going to get 100 over negative 2, which is negative 50. Okay, so that is how quickly the stock is decreasing in value over that interval. So then they want us to find another 2-month interval where the average rate of change is faster than that. So if you think about this, we can look at something even the next interval down. If you look like at 12 to 14, look how quickly that one is dropping from 225 to 85. So that's even more than 100. And that's still over 2 months. So we could use that interval. So I'm going to say between 12 and 14 because the difference in the stock's value is more than 100. So if we really wanted to prove it, we could say, my 2 points were 12, 225, and 14, what was it, 85? And so if I do the math, 225 minus 85 over 12 minus 14, that's going to give me 140 over negative 2, which is negative 70, which clearly is faster decrease than our first interval. Okay, one more about this. Are there other 2-month intervals where the rate of change is the same as 10 to 12? Explain your answer. Okay, so if there's another 2-month interval where the rate of change is the same, we would see that symmetry in our table up here. So let's go back up. What did we look at before? 10 to 12. Okay, so 10 to 12 is what we were comparing to, and we want to see if there's another interval that has the same rate of change. Well, we knew before, because we wrote this down, that 0, the starting value, was 225, but if you think about it, that rate of change is going to be positive because, let me do the work over on the side here. So 0, 225, and 2, 325. So if I do the slope, 325 minus 225 over 2 minus 0, I get 100 over positive 2, which is positive 50. So even though it might seem like the rate of change is the same, it's not, because it's increasing, it's not decreasing. And so the answer to that is no. There aren't any other 2-month intervals where that rate of change is the same. So we'll say no because as how do I want to phrase this? I'm going to actually change that. No, because as time goes on, the rate of change increases. I guess you could also explain this as no, because this is not a constant rate of change, so there is never going to be the same exact rate of change in here. All right, we have one more. Number 3. A toy company is manufacturing a new toy and trying to decide the price that will result in a maximum profit. The graph below represents profit P generated by each price of a toy. Answer the questions based on the graph of the quadratic function model showed below. Okay, so let's go down to some questions here. So if the company wants to make a maximum profit, what should the price of a new toy be? Okay, so if they're asking about maximum profit, that means I am looking for my maximum point. And remember, your Y value is your profit, and your X value is the cost per toy. And so they're asking what the price of the toy would be, so we want to say 6 because that's the X value of that point. So we would say $6 would have to be our price of the toy for our profit to be a maximum. Part B, what is the minimum price of a toy that will produce profit for the company? Explain your answer. Okay, so profit can be thought of basically anything greater than 0. Okay, so if you look at your graph, the minimum price that the toy can be, let's talk about this. If the toy is $2, we're not making any profit, right? The amount of money, we're kind of broke even at that point. And so anything more than $2, even if it's $2.01, we're going to start making profit. So you can write this a couple ways. We can say $2.01 or X is greater than 2. Either way. And we'll say because, to explain, anything less results in a loss or breaking even. A loss meaning our profit is in the negatives. Breaking even means our profit is 0. Okay, estimate the value of p of 0 and explain what the value means in the problem and how this may be possible. Okay, so this means when x is 0, we're estimating what our y value is. So when x is 0, we are way down here. And it looks like, I don't know, maybe we can call that about negative 193. That looks about right. So I'm going to say p of 0 equals negative 193. And what does that mean and how is that possible? So basically it means if you are selling your toy for $0, you're giving them away, you are going to have a loss of $193. Okay, and why is that possible? Well, it makes sense, right? If you're just giving away these toys, you still have to pay to produce them, and so that is going to make you zero money. You're going to be in the negatives. So let's see, explain what the value means. So let's say if the toy sells for $0, the company will be at a loss of 193. Okay. Part D, if the company wants to make a profit of $137, for how much should the toy be sold? Okay, so remember profit is Y, so I'm looking for on my Y-axis, where am I seeing $137? Okay, so I see 137.5, so maybe just below it. Oops. Looks like maybe about here. And then remember, our parabola comes back down. It's symmetrical. So on the other side, we have, oh my goodness, we have another spot where it could be about that much. So it looks like we can go with about $4.50 or $7.50, right around there. So $4.50 or $7.50. Okay, for E, find the domain that will only result in a profit for the company and find its corresponding range of profit. Okay, so domain, this is our x values, left to right. What numbers on our x-axis are going to give us a profit? So we've already talked about how at $2, we're not making a profit, but anything more than 2 we are. And if we think about following that curve, we're going to have a profit all the way until we sell that toy for $10. So the way that we're going to write this, because it wants it, well, it doesn't say, let's do interval notation. So for the domain, we're going to say 2 to 10, but we are not going to include 2 or 10 because at those points, we're breaking even. We're at 0. And remember, profit is considered more than 0. Okay, and the range. So we're really only looking at the part of the graph that starts at the x-axis and goes up. So the lowest point that we can make profit would be 0. And the highest point, I think we said, was about 164. Okay, so again, we're not going to include that 0 because we're not making any money when it's $0. But we can include the 164 because that's considered profit. So we will include that. Okay, part F. For which interval is the profit increasing the fastest? Okay, so let's go back up to the graph. So we are looking first between 2 and 3. So if I just kind of look at, I'm going to put a point right here. Okay, so between those 2 points, and we can just eyeball this one. I think you guys are going to be totally fine with being able to just see this. Between 2 and 3, the rate of change looks like it's increasing pretty quickly. If I look at between 4 and 5, here's 4. Let me get rid of these other points now. Here's 5. It does not look like it's increasing as quickly. 5.5 to 6.5, we're not really increasing at all. We're going up and then going right back down to the same spot. And then 6 to 7, 6 to 7, again, minimal. So just based on what we can see, 2 to 3 is where that profit is increasing the fastest. Now, if you had to prove that in some other way, you could find the slope between all of those points and find the one that has the highest number. Okay, last one. The company owner believes that selling the toy at a higher price will result in a greater profit. Explain to the owner how selling the toy at a higher price will affect the profit. Okay, so we can see from the graph that if we start raising the price of that toy, at first, the toy is still selling, right? We're still making profit. But once you hit that maximum point at $6 and you start charging more, your profit decreases. So what's probably happening is you've priced the toy at too much money. So your sales are going down and you're not making as much of a profit. So at some point, that $6, it is not beneficial to increase the price anymore because your profit is starting to decrease. So let's see, let's try and get that in words. So I'm going to say if the selling price is more than $6, the profit begins to decrease. Okay. All right. So that is all interpreting quadratic functions. We are going to get into some word problems next. So the next lesson will be more about that, and you're going to need probably your graphing calculator for those, but that will be lesson 3.